Hello everyone and welcome back to another video. In this project, I'm going to describe the IoT-based health monitoring system. I'll be monitoring a number of health parameters like body temperature, heartbeat per minute, and the blood oxygen level, including the room temperature and room humidity as well. But I won't be able to monitor all these parameters in a single project in a single code. That's because of the fact that the microcontroller, the memory of the microcontroller cannot take the load of the entire project. I will be describing the reason why. Well, that's because of the fact that the measurement of the blood oxygen level works on basis of the collection of a number of samples from the MAX 30102 sensor. So it happens that it has to collect data or samples of unsigned long integer type, and in 4 seconds the sensor extracts around 100 samples. So each of these samples are of unsigned long integer type. So in order to store all these samples, you have to define an array of a buffer length of 100. So if you define such kind of arrays, such kind of 2 arrays, in that case it will consume around like 100 length and each of 32, so 3200 bit for each of the array. That means 800 bytes. So 2 array will consume 1600 byte. But the Arduino Uno board will allow you to allocate around 2048 bytes for global variable. So what happens in this case is that if you try to compile the entire project code into the same board, then it happens that the board cannot take the load because the allocation of memory for global variable exceeds in case of the entire project. But if I run or monitor all these health parameters individually, then it works fine. So it's one of the major issues I faced, while going through this project. So I'll be splitting the entire project into 3 parts. In the first part, I'll be monitoring the body temperature. In the second part, I'll be monitoring the heartbeat per minute. And finally, in the third part, I'll be monitoring the blood oxygen level, also known as the SpO2, which is oxygen saturation in a person. So first of all, in this project, I'm going to describe the body temperature monitoring, including the room temperature as well, room humidity monitoring as well. So first of all, I will be describing the components that I've used here, and then I will describe the feature of my project, and finally I will demonstrate the way my project works. So first of all, as the microcontroller, I have used the ESP32 board, which has its onboard built-in Wi-Fi that will allow me to extract all the data, all the health parameters, as well room parameters to a dynamic web server, as well to send an alert by an email. I have another microcontroller over here, which is the Arduino Uno board, but I haven't used it in order to compile my project. Rather, it's only been used in order to, as a part of power supply. I will tell you shortly the number of sensors that I have and the number of supplies that I have provided in order to power up the sensors I have used here. So next, as the GSM device, I have used the SIM900A GSM module, which will be eventually used in order to send SMS to the doctor regarding the health parameters. And as you can see that the SIM900A GSM module has been established on network as the status LED is blinking once in every 3 seconds. So it's established on network. And remember to power the SIM900A GSM module with a separate power supply, which is right over here, because it requires constant power supply in order to send or receive SMS, to work properly. So in order to ensure the smooth operation of the SIM900A GSM module, make sure that you are supplying it with a separate power supply. And it's powered by 5 volts. So these 2 batteries supply around 7.5 volts, and the power and the voltage, I should say, has been stepped down to 5 volts using this voltage regulator 7805. And then in order to measure, to monitor the room temperature as well room humidity, I have used the DHT11 temperature plus humidity sensor module. And then in order to measure the body temperature, I have used this waterproof thermal probe. You can also put it in your mouth and measure the body temperature. But once you're putting it into your mouth, make sure that you are cleaning it so that it can be used for the second time for someone else. And then for designing the user interface, to prompt the user, I have used the 4-channel touch capacitive sensor. I have used the 1st and the 4th channel. I will show you shortly in my demonstration. And finally, in order to design the user interface, I have used the 20x4 LCD display, I2C LCD display. It has an I2C driver just below it. The use of the I2C driver allows me to work only 4 wires, so I will get more number of ports available to my microcontroller, to work with. And now let me tell you the way I have, another fact I would like to mention about the waterproof thermal probe is that it has 3 wires, as you can see: the red one, the yellow one, and the black one. The red one, in case of the red one, you are going to supply it with either 3.3 volts or 5 volts, but as I'm powering everything with this, as I'm working with the ESP32, I have to power everything with 3.3 volts. So it's been powered. The red one is the VCC cable, the black one is the ground cable, and the yellow one is the data cable. And I soldered it in a portion of the Vero board, as you can see, and in between the red and the yellow wire, make sure that you are putting a resistor of 4.7 kilo ohms. So it's very important to remember. And let me now talk about the power supply. The same 900A GSM module has been powered by a separate power supply using this pair of batteries. And all the other components, not all the other components, this LCD display has been powered by 5 volt from the Arduino board. And all the other sensors like the 4-channel touch capacitive sensor, the DHT11, and the waterproof thermal probe, they have been powered by 3.3 volts. They have been biased by 3.3 volts from Arduino. Make sure that you are energizing them with 3.3 volts, not with 5 volts. Even if you are doing so, make sure that you are stepping down the data voltage. You know why? That's because of the fact that the ESP32 board is not 5 volt tolerant. So if a sensor is generating a control signal of 5 volts, if in case it's biased by 5 volts, make sure that you are stepping down the voltage with the voltage level shifter. Like you can use the DC to DC buck converter LM2596 in that case. But in order to avoid the use of any kind of converters or voltage level shifters, I have biased all these 3 components with 3.3 volt. So only the waterproof thermal probe has been powered by the ESP32 board, and the other sensors like the 4-channel touch capacitive sensor, the DHT11, they have been powered with the 3.3 volt from the Arduino board. So that's all about the components that I've used here. And right now I'd like to describe the feature of my project. So if you press a button, then you will be able to measure or get the body temperature using this waterproof thermal probe. And if you press another button, I mean button number 4 in that case, I've defined it in this way in my code, then you'll be able to send the alert by an SMS as well by an email to the doctor about your health parameter, like in this case the body temperature. At the same time, the room temperature and room humidity will also be sent to the doctor, and all these parameters will be monitored in the LCD display in real time as well. So right now I'd like to directly dive into the demonstration, the way my project works. So in order to do so, I'd like to start from the very beginning. So I'm going to reset the ESP32 board. Show you the demonstration right now. I ran into a problem, so I had to pause the video. So I'm going to reset the ESP32 board in order to start from the very beginning by clicking on this button. Yes, I've been able to reset the board. Welcome to Rafi Smart Healthcare Undergrad Student Department of EEE BUET. So that's the introductory screen. And the GSM module is also established on network, as I can see. Let me open the serial monitor to observe. Yes, it's working fine. It's also connected with the internet. As you can see, it's established on GSM. You can see from the previous text, and the IP address is also available of the Wi-Fi. So it's working fine. So it's telling me enter 1 for body TP, which is temperature, and enter 4 to send message. TNH means room temperature and room humidity, which is currently 29.6 degrees Celsius and 53%. So if I press on 1, then I'll be able to get the my body temperature, and I'll be putting this inside my mouth, and it will get the temperature for 40 seconds in order to stabilize the readings. So I will be measuring my body temperature for the next 40 seconds. I won't be able to talk as I'll be measuring my temperature. You see it's more or less close to the standard body temperature, which is 98.4 degrees Fahrenheit. Right now I'm inside the air conditioner, so it's very obvious that the body temperature will be slightly lower, not that much. But if you give more time to the thermal probe, if you run the while loop for around 60 seconds or for around 100 seconds, then the temperature reading will stabilize more, and in that case it will give you more precise reading. And right now, if you want to send this alert to the doctor by means of an email or by means of an SMS, simply you have to press 4, as it's telling you enter 4 to send message. So I'll be clicking on 4 right now. I have already clicked. So as you can see, sending first alert, please wait a bit, which will be the email, I should say. And you can see the progress on the serial monitor, whether the mail has been sent or not. Yes, it's in progress. It's been connected with the server and it's about to be sent. Sending second alert, which will be an SMS, and both of these alerts have been sent. So right now I'm going to show you both of these alerts, whether they arrived properly. So first of all, I'm going to show you the mail alert. I'm going to refresh the page, but before that, I'd just like to show you the alerts, what they are from. Alert from Rafi's Healthcare. The subject is health alert. I'm refreshing the page and I'll show you the very last mail that arrived at 12:43, 0 minutes back, and right now the time is 12:44. So the last mail is body temperature 97.4 degrees Fahrenheit, room temperature is 29.7 degrees Celsius, and humidity is 54%. And right now I'm going to show you if the message arrived properly onto my cell phone. So as you can see, the very last message from Home Alert, the very last SMS that arrived at 12:43, body temperature 97.47 degrees Fahrenheit, room temperature 29.7 degrees Celsius, and the humidity is 54%. So the monitoring as well, the alerting system is working perfectly. Maybe it looks a bit messy. I haven't furnished my entire work into a single project board, but I believe that I have been able to clarify myself. In the next 2 videos, I'll be showing you the monitoring of the heartbeat per minute as well the blood oxygen level. So stay tuned for the next one. Bye for now.